Welcome everybody to my first really true open Q&A live stream. And so I mentioned this if you've been on my channel following. I've been doing some live streams obviously over quizzes and over homework, and then yesterday I did a final exam review. But today tonight what I basically wanted to be able to do is just kind of answer some of your questions. So I did put out a post at least on my community tab just to kind of see some questions, anything that you guys can that you kind of still need help with. And I know some of you guys are done with your semester exam, and if cool, that's, awesome. If there's any other questions, as you guys are moving into the next unit or that are still around, I am here to answer those questions. So I do not have any game plan for this live stream. I'm basically going to be feeding off you guys that are going to be in the chat. So, hey, Arsam, Muhammad, how are you guys doing? So so when you guys have some questions or you want me to tackle a certain subject, please feel free just to type it in and I will try to do my best. I have noticed as I've been going through my live streams that, if I'm doing a math problem or if I'm talking, I've noticed that I went back through the chat. I missed a lot of your guys' questions. So I do apologize for that. I always try to make sure I can, at least give you guys a shout out or address a question if you have. But just kind of depends on how much traffic and everything is moving through. I might miss your question. So I do apologize for that. The other thing, just to let you guys know when you are typing in, a question or if you want a content, if you can give me preferably a specific problem or a certain process that you want me to really zero in on, that will help me being able to make sure that, what I am explaining is going to be conducive, to your learning. So I did get a couple requests that were, just some generic processes or topics that I can cover if obviously you guys on the live stream don't have anything else that you initially need. One of the big things that was kind of a big topic was piecewise function. So I'm going to start off this live stream just kind of explaining piecewise functions. I think one of the big things, and I don't really cover it a lot in my class, is identifying the domain and range of a piecewise function. So, we did talk about it in my class, but it's not something that we do a lot of problems on. We look at evaluating piecewise function and knowing what the graph looks like and the discontinuities, but we don't really talk too much about the domain and range. So I am going to kind of do like a fairly basic problem. I'll do a fairly basic problem with that. And so therefore we can kind of like understand the domain and range. All right. All right. Do substitution. Stop, please. Can you give me a shout out? Yes. Muhammad Nafzumen. Sorry, I can't say your last name, but hopefully I got somewhere right out there. But yeah, there's a lot of you guys joining in. That's awesome. So Andrew Camuto says, do you do substitution? I'll make one up. I don't have problems up here. So I'm just going to have to kind of wing it here, and hopefully I can get a good problem for you. Taxes, hi, Nudge. You're awesome. Let's see. Can you do a live stream on division? Sure, but what kind of division are you talking about? Bryson Dra, can you tell me the difference between exponential function and logs? All right, so let me try to write some of these things down. So I'm going to start off with piecewise functions. And I'm just going to explain piecewise functions, basically talking about the graph. Oh, you guys can't see that. Sorry, I forgot to change it over. All right, let's look at my screen now. Now I'm not so much big. So we're going to talk about piecewise functions, how to graph, and then domain and range. Now I'm believing you mean substitution as far as systems of equations. And I don't know what division is, so I'm not going to write that down until you tell me if it's like division of polynomials, division of numbers, or fractions. Yeah, so I'm not really sure. So hi, could you help me with polynomial division? Sure. Do you have a preference as far as, Camille, do you have a preference with long division or synthetic division? And see what book type of division you can teach me. Yeah, so if you let me know, trig identities. Trig identities is... those are kind of hard for me to make up. So if you have access and you can do your best to try to like type an identity, I can go over some basic ones I can like make up in my head. But as far as that, you would have to like watch me kind of like create one and then and then I would verify it. So it might be a little kind of backwards to do it, but I can create an identity. It just might be a little weird. So if you have one maybe that you want to work on, then we can do that. So synthetic division, okay. So we'll do synthetic division. We're also going to talk about exponential and logs. L1 plus 1 equals 2. What does 2 plus 2? Okay. So, so this will just be a overview. I'll do an example. I can make one up for synthetic division. That's not an issue. I'll do example here. Let's see here. Hey, talks to be my teacher. Well, yeah, I am your teacher. I'm just your teacher online. So that's what I have all my videos, and basically, I mean, everything that I teach in class, I mean, you guys get access to. So let's see what else. So we have trig identities. I'll see if I can remember one. Did I keep? I might have some copies at home. I'm not sure. Polynomial division. I think I got everything. Can you use some word problems based on quadratic equations? Unfortunately, are some. I don't really have anything as far as like a word problem presented, or at least that's not something prepared. So that's a little bit harder for me to be able to create a word problem. What I can do though is kind of talk about some. That's a 6. What I can do is talk about, as far as a word problem goes, what are some things that you're going to want to make sure you can do for a quadratic word problem, and hopefully that will like help you out. And typically with the word problems, you know, they're using some numbers that are a little bit more realistic, so therefore the math is not really going to work out as well. So more likely you're going to have to use a calculator, which, you know, I don't have as well with me right now to be able to solve something. And let's see, is there anything else that I missed? Could you go over trig identities? Yes, Ryan, I will try to do my trig identities best I can. All right. Vlad says he passed with a 96 in college algebra. Good job, Vlad. That's awesome. And Camille helped your videos. All right, I think I got you here. Thank you so much for joining. All right, by the way, can you do decimals? Yeah, just let me know what you want. Decimals, fractions, like division, like do you just want me to like to divide numbers, to divide fractions, to divide decimals, like me guy says, please do Euler's method. Unfortunately, I am a little bit further away from doing Euler's method, so it's been a long time. It's not something that I'm currently teaching. So unfortunately, that's not something I'm going to feel is like in my wheelhouse, or at least prepared to, you know, work over. So unfortunately, I'm not going to do that. And even anything on the calculus, even though I've been teaching it and obviously have my degree, it's been so long since I've done so many calculus problems. And even like the last 2 years, like I was helping a student, my aide actually, she was doing her calculus, and it's like crazy how much you forget if you're not constantly doing the math. And I think that's like, you know, the one thing that also just reminds me, even as a student, like, you know, obviously when I'm doing math every single day, it's very easy to like, you know, teach it and to make those connections. And like, I took a year off from teaching calculus. I'm not teaching it this year. And it was like, I was looking at the problem and I was helping her. I'm like, oh my God, I'm like, I already forgot my thing. And it took me like a couple minutes to be like, oh yeah. Now I know. And then I could do my explanation to help her out. But it was just so funny. I'm like, man, just like it didn't take very long for me to like not have that immediate, you know, confidence as far as what I was doing. So unfortunately, Euler's, sorry. I don't know why things. Yes, Euler's method. As far as what I would be able to do with that. I don't know why it's what was the thing, the Euler's? Yeah, I know, the Euler's, Euler's, I always make fun of too. And what was the other one that I always, well, yeah, either way. All right. Hey, the kid gamer. Hola. Solve radical equations, please. I am desperate. Okay, I will try to do my best to solve radical equations. And then I have a math rally tomorrow. Wow, you guys really gonna jump in from that? It's all right. I mean, I should have caught myself, but whatever. It's again, I've mispronounced and said things in there, but yes, I am aware it's Oilers, not the Eulers. I don't know why it kind of came through and going through that, but whatever. It is what it is. Again, as I mentioned, it's not something that I'm actively teaching or it's been around. So immediately just with the live stream comes out the way it comes out. And then obviously I'm thinking of other things. So it gets that. So whatever. All right. Yes, exactly, Vlad. That's exactly where I was thinking. I mean, obviously it's important, I think, to pronounce things obviously as they are and correct. Like the same thing, like when my students say sin instead of sine, it's like, well, no, that's a completely different thing, or cos instead of cosine. So it's, some semantics thing is as far as making sure that we are obviously pronouncing things, incorrectly, but, just totally kind of dropped my mind from that. So anyways, like I said, I'm going to move on. It's not really anything I'm concerned about at this point in time because I'm not going to be able to work on it because it's not something I have been doing anytime recently. All right, hold on. Did I miss this? Solve radical equations. Yeah, just any decimals that can be in my fourth grade. I'm sorry, Mohammed. Unless you can give me like an example, I'm not really. And then I'm not really sure. I'm not really comfortable with fourth grade math. Not like I can't do it, because obviously that'd be kind of weird. But the fact of like a correct approach, and as far as like the showing, like obviously I can just show you what the quickest way to do things, as far as solving, but a lot of the math that we've come up with, there's actually some different approaches that we want to think about something. And to be honest, I haven't really thought about the fourth grade math. That is one thing that I do want to kind of go back into and look into the way that I learned math, and then also the way that we're kind of learning math, and really kind of see what makes sense, because there are some changes that I'd like to kind of address with that. But my main thing is, if you have anything in decimals, just multiply by, usually you can get it out of your decimal form, especially if it's like to the 10th, just multiply it by, 100 to eliminate the decimal. But obviously you can work through decimal operations. It's just nobody really needs to do decimal operations. You're either going to use a calculator or you're going to use shortcuts. All right, square root of 2x plus 5 minus the square root. Oh, we got an example. All right, let's do this one. So, or maybe not. Yeah, so we have... All right, square root of 2x plus 5 minus the square root of 3x minus 2. Oh, man, I forget. Equals 1. I'm trying to remember what the best thing I'd want to do. You're going to have to check for extraneous solutions. And I guess you can't square, but anyways, I'll get to that in a second. All right, you guys are now throwing in a whole bunch of answers to me. Is this it, or are you guys like building me up? All right. Oh God. Okay. This might have been a bad idea. We might be here all night. All right, so I'm going to go up to 12, and then that's going to be my limit, because obviously this live stream will get to be way too long, and obviously I want to be able to spend some time. But that's part of solving rational equations. Please do polar coordinates. And then we have another one. No, that was that one. Find and simplify the difference quotient of h not equal to 0 if f of x equals x squared minus 2. Oh, that's something I haven't done in a long time, the difference quotient. So basically you want to do f of x equals x squared minus x. And then basically you're going to simplify now, or f of x, find and simplify. So we're actually just preparing for the difference quotient, because you're just going to evaluate f plus x plus h. And then try to simplify it. Minus f of x over h. Cool. And then another one, I don't know what that's an exponential. That's like exponential raised to an exponential, Vlad. Or it's 2x raised to, or 2 raised to the 2x squared raised to the 3x. I'd have to see. I don't teach exponential. So we have 2 to the x squared. I'm going to have to use a calculator for that one, but I can at least set it up for you. 3 equals to the x. What does 2 to the x to the negative 2 equal? Okay. We probably have to, I'm trying to think about my brain, see if I can help you guys out with that one. Man, you know what? That's the thing that stinks about the live stream is I got to like off the cuff go on a thing and rational equations. I will get to the rational equations for sure. Trust me. When do I learn algebra? Depends. Usually 8th grade, 9th grade. So he's doing it. Low-key faded because you need to know before approaching trigger calculus. I want to become a math teacher when I grow up, and that's awesome. Best of luck for you. Just keep on working and enjoy the time. It's a great occupation. That's a great advantage in someone who only has studied math for years. That's right. Can you do a mathematical induction? I can, but it's the same kind of thing, guys. It's been like way too long since I've done induction, so it's not going to be something that I'm going to be very comfortable as far as like I can work through it and obviously work through it on my own, but obviously for a live stream, I want to be able to like quickly kind of go through things and confidently give you a good explanation rather than like working it out again in my brain because it's been so long. No, I can't do the St. Petersburg paradox because off the top of my head, it's not coming to me what I need to do, and I'm just not familiar with everything. SLV saying can you talk about derivatives? I can, but I mean, that's kind of like not just like a short little thing to talk about. That's kind of a important thing. I can give you like the basics of the derivatives, but I don't think derivatives is something. We could rush into it and just go into some quick things, but I don't think that's really going to do you much service. We can just talk about as far as really the looking at the definition and stuff like that, but that's not when I'm teaching derivatives, obviously we spend like a lot of times looking at, the derivative, looking at applying the limit with it, and really kind of understanding it before we get into the mathematical operations. And solve absolute value equations, that's always a good one. I can do that. And good call. Can you make another live stream sooner or later? Obviously, but just like saying, yes, I might be going live on tomorrow. We'll see how my schedule works. Please do the inequality. All right, I can do, is that 8 over? So 12. So I have 8x divided by 6 minus 8 is greater than 2x. Cool. Sequences and series. I would love to do sequence series. I'm kind of like at my max. Oh my God, I can't do everything. I just remembered, can you help me on area and perimeter of 4th grade math? I'm not sure though as far as what you need to know for area and perimeter. I can go over the basics of some figures, but I'm not sure what else can you do. Does he do pre-calc? Yes, Anna, that is basically all I'm doing this year is all pre-calc. I'm just doing some random questions that people have. Oops, sorry, forget, you don't teach calc anymore. Yeah, I just not teaching it this year. I taught it for the last 2 years. So, that's, I can do induction or segmentation and Riemann sums. I could. It's unfortunately just for this live stream, I'm not going to be able to get into that. And again, that'd be something that I'd want to, go back over. Can you do factoring polynomials? All right, I'm just going to do one more factoring polynomials. Obviously, guys, what I'd like to be able to do is obviously have some different streams. Like, for instance, like Mohammed, like doing some ones for some earlier math, like before, like pre-algebra and before, pre-algebra, algebra 1, getting into the calculus and so forth, because this is just going to be like a hodgepodge of basic topics that we're going to cover here. But hopefully, if you have some questions, hopefully I can kind of touch on some ideas for them, and hopefully that can help. But I am going to have to end off, guys, on the questions because I have to go soon to sleep. Yeah, I'm sorry, Mohammed. I mean, I'll try to. Obviously the replay will be up, so you can definitely go ahead and take a look at it. As far as when I cover some area and perimeter, but I'll try to do these as much as possible as quickly there. So let's just kind of real quick go over piecewise functions, and then I'm just going to work down my list. And I do apologize for those of you that do have some questions but joined in the live stream late. Obviously I can't spend that much time doing that many questions, as they're kind of coming in faster than I'm going to be able to solve them. I'd make sure you change the title of the live stream so you can track more people to the stream. People may be confused by what you're going over. You're right, and I don't even know what I'm going over either. So if you have a good title or good description for the title, I would love it. I thought the open Q&A was basically what it is, because I'm just covering everything. I mean, there's 14 different topics here, so I'm not sure what would be the best to do. Yes, I have two little girls who are asleep now, so that's why it allows me to do this live stream tonight. Can you go over half angle formulas? I will, Anna. We'll be doing that very, very soon in my own class, so you'll start seeing a lot of content coming up on there. And then, but yeah, and then obviously my channel, I have a ton of half angle and double angle and sum and difference formulas, but we're not going to cover it until next year. All right. Let's go ahead and get on to some piecewise functions. Just real quick, let's go and take a look at, I'm going to make one up. And let's see if I can pick one that is going to be, let's see, x plus 2, and then that's 2, yeah, and then this is going to be x is less than 1, and then I'll do x squared, and then that's going to be from negative 1. Oh, shoot, I gotta graph this. I can't visualize this. There's 2, up, 1, down. Yep, okay, I was right. So that's going to be from negative 1 is less than or equal to x, which is less than or equal to, let's do to 1. And then from here, we're going to do 3, where x is greater than 1. Okay. So let's pretend you have a piecewise function, something like this. You have a linear equation, two linear equations actually, and then you have a quadratic. Now, again, the main idea here is the function is just the name of the function. We obviously have this bracket because we're grouping these functions together, and then each function has a restriction on its domain. So what I like to do when I'm first teaching piecewise functions is to basically just graph all of them. Until you get used to this process, just graph every single one of them. Down 1, down 2. There's that graph. Oops. Let's do this. Okay, so I'm going to do it this way. So we have this graph. There. There's the linear graph, number 1. That's equation number 1. Here is our quadratic. This is number 2. Nice, good old parabola. And then here I have positive 3, which is going to be, did I really pick? Yeah, I think I did. So this is going to be number 3. Actually, you know what? Let's do this. Let me eliminate that. Okay. And then this is just going to be a horizontal line. All right. So those are all the functions. Function number 1, function number 2, and function number 3. But again, you guys got to understand these are restricted. We're only graphing function x plus 2 for x values that are less than negative 1, not 1. So here's negative 1, right? If you look at the x-axis, here's negative 1. We're only going to graph values to the left. That means everything to the right we are going to erase. It's not a part of the function. Then we look at x squared. Well, x squared is only going to be defined for values between negative 1 and 1. That means everything to the left of negative 1 and everything to the right of negative 1 is going to be not a part of the graph. And this is actually an open circle because I changed that. And then this last one is 3, which you can see this equation here, but that's only going to be defined for x values that are greater than 3. So therefore, I can just delete that up, right? So basically, when we're graphing a piecewise function, and we'll get to the domain and range in just a second, we're basically just taking these 3 graphs and putting them on top of each other. So let's go ahead and, I'll just do it over here. Let's go and put them now all together. So I have this one, which is down at -1, -1. Then I have this nice little graph here, shares that point. And then this one has a closed circle. Oh wait, I changed that to a open circle, didn't I? Yeah, so that's an open circle as well. Okay. There you go. All right. So that's what that graph would look like. That is our piecewise function f of x. Now, to identify our domain and range, basically what we're going to be looking for is, looking for the range is obviously like how low is the graph going to like how high is the graph going. All right. So let's go ahead and let's just write over here. So you can see that this graph is continually going down to negative infinity. Like it's going to keep on going down and down. It has no limit, no restrictions on how low it can go. So the lowest value it's going to go is to negative infinity. And then obviously it keeps on going, but it seems like it reaches this maximum value of 1. But then it dips back down, and then it looks like it comes really, really close to 1, but not actually evaluating to 1. But either way, we know that the range covers from negative infinity all the way to 1. So that is going to be included. And then we have a second version of this graph, which you can see that even though it's not a value here, it is going to be a value in from, as far as this value, you can see as far as this value is, go ahead and get defined. And I've actually never really come across this as far as what I would graph that as far as the notation to value at 3, because different points is valued to 3. I don't know if this is mathematically correct or not. I don't know what I would actually do on that one. Obviously, it's not something that I've come across in all of my problems, so it's definitely not something that is very common or something you'd see, but hopefully we'll just kind of see. I'm not sure if that's the best version. A lot of times we either have it like going towards infinity or something like that, or going back down, so you can have like this max or min. And now as far as the domain, that's basically asking us how far to the left is the graph going to how far to the right is the graph going. And I don't know, you might just like have a bracket there with 3. I'm not sure. I would actually have to look that up. It's not something, again, as I've talked about, we covered a lot. But anyways, domain range is up and down. So the domain, we're basically looking at how far to the left is the graph going, which would be from negative infinity. And then as the graph continues to the right, you can see that at 1, the graph is undefined. So therefore, it's approaching 1, but it actually never actually reaches the number 1 because those are 2 holes. So therefore, we're going to use our parenthesis here. And then we're going to use the union symbol to combine, because after 1, which is undefined, or which is not included, the graph continues down to infinity. And therefore, you can see that notation there. So that's something obviously we use. Again, this union symbol is just conjoining these 2 different ranges. But basically what you want to do when finding the domain and range of a function is graph the functions, put them together, and then basically kind of understand where the function is defined or not defined from in there. And again, I'm just still kind of curious on that. I'm like, man. Parentheses, left side of 3. Parentheses, left side of 3. Right, but I'm not sure if I just put if I should just use it as a 3. Or just leave it as a 3, 3, because it's from 3 to 3. I'm not sure what would be approved or not approved. Very good. All right, so let's go and work on the next one, substitution of equations. So very, very common one. I'm going to have to kind of like I'm going to have to like create an equation here. So let's just do something. 2x plus 1. Let's see here. So up 1. Up 1, and then 2x, what am I doing? Plus 1 up to over 1. All right. And then let's do 1, 2, 3, 4. So I do y equals negative x plus 4. All right, I think I can make that up. So here is, I think I got it. We'll see how this works. So let's pretend we have an equation, y minus 2x equals 1, and then y plus x is equal to 4. Now, obviously, I'm just doing a very basic equation because that I had to create one on the fly for you. Obviously, the same process works. You know, sometimes you're going to have some different things, but the main important thing when you're doing substitution, you're always going to have, or you should at least want to do substitution when your coefficient of your x or your y is equal to 1. Now, in this case, x and y, we actually have two y's, both have a coefficient of 1, or my x is a coefficient of 1. So it doesn't matter which one you want to choose to isolate, but you need to solve for a variable. And the easiest way to do substitution is when you have a variable with a coefficient of 1. Sometimes it's like only one variable, so obviously that's the one you use. In this case, we have an option. We could use the y here, we could use the y there, you know, or we could use the x. So I am just going to decide to solve for x. I don't know why. I'll just choose the x. So what I'm going to do is just on the sidebar, call this my sidebar, I am just going to have y plus x equals 4, and I'm just going to solve for y. Okay, I'm not taking this as a, like one way is better than the other way. I'm just deciding that I want to solve for x. All right. Now, what do we do here? Well, again, it kind of goes back to like just a basic equation. You know, when you had, you know, x plus 2y, and I said x equals 2, and no, let's say x equals 3, and y equals 4, and we would say evaluate. Right? Well, then what you would do, you just plug a 3 in for the x, and then you plug a 2 in for the 4. And then you found the value. 2 times 4 is 8, plus 3 is 11. Right? But basically what you did is when we know the value of 3, we replaced our variable x for our equation. Or, sorry, for our expression. We replaced the value of x of 3 with x, and then we go ahead and evaluate. So that's the same thing. We now have a value for x. X is now equal to the expression, not the value, but the expression 4 minus y. So what we can do now is replace our top equation with that expression. So when doing that, I will have y minus 2. Instead of multiplying times x, I'm now going to replace that with what the value of x is from the other equation, which is 4 minus y. And that is going to equal 1. Now, I just need to basically solve for y, so I'm going to apply distributive property, and I get y minus 8 plus y equals 1. Combine my like terms, that's a 2y equal, or 2y minus 8 equals 1. Crap, did I get that right? I thought I had that. Did I pick that one? 2y, did I either make a mistake or did I choose a problem wrong? So if we're up to 2, up 1, over 1. Oh no, I must, wait, no, up 1. Yeah, that's right. Okay. And then down 1 over 1. I'm not getting this point. Oh god. Alright, what did I do here? I'll plug that in. X plugged. That's a negative 2. That becomes a negative 8. Oh, that's a positive 2. No wonder. Somebody catch it? No? No? Who knows Nico Bellic? Yes, thank you. Did distribute. Vlad, awesome. Good catch. So yes, and you distribute that, so that actually becomes a 2y. And therefore, this is a 3. Let's just eliminate that. All right, so y minus 8 plus 2y equals 1. Therefore, that's a 3y minus 8 equals 1. plus 8 plus 8, and I'm showing all my work. You're welcome. Divide by 3, y is equal to 3. So now we know the value of 3, and it's just like here. We actually have a value of y. So now what we can do, God man, this has like been such a long time. So now what we can do is just plug in the value of y to solve for x. Now you can do any equation. You could plug it into this equation, you can plug it in this equation. But I would say the best equation to plug it into would be x equals 4 minus y. Why? Because x is isolated, right? So let's evaluate the value of y for this in this equation. So then we say x equals 4 minus, and then we're just going to plug in 3 because that's the value we found. And therefore, you can see x is equal to 1. Now, again, like what is the solution point? And this is a solution point. You have a value of x and y, which makes the equation true. So we can say the solution in this case is the coordinate point 1, 3. If you were to look at this graphically, which is the way that I got this problem, is I basically just sketched a graph. And so I went up to 4. And you can see the point 1, 3 is where the two lines intersect. So substitution is a great process, but I would say it's most useful when you have a coefficient of 1. And so yeah, otherwise you'd probably want to look into the elimination. And I'm sorry for some of you guys that are coming into this a little late. I have a whole bunch of questions that I'm going to get into right up here as far as doing all of these, and so I'm not taking any more additional questions for you guys, so I do apologize for that. Read the chat, you, Brian. Yes, Ryan. All right, well, I can see what you have. No, 9. Yes, I got that correct. I don't know what a delay it is, but yes, I got that. Express the equation of the line in form y equals we given the form. Okay, well, Ryan, if you're going to have to, I don't know how to do that. Ryan, do you play? No, I do not play chess. All right. Yes, I can drive. I have a video read for completing the square. We can get into it, but let's. All right, let's go ahead and get into what was next. Synthetic division. Okay. So, synthetic division. I am not going to do one that's going to have a 0 because then I have to create that problem. So I am just going to do a basic problem, and hopefully I pick one that's not going to have a large remainder because you can easily make an issue out of this. So let's just say we have f of x equals, let's do x squared, or not x squared, let's do at least a cubic, x cubed minus 2x squared, plus x plus 4, okay? And therefore, basically, if we want to divide this by x, let's just say minus 1. I'm going to try to keep the numbers very simple. So again, there's a couple things that we need to understand. Like when we're doing synthetic division is just a tool. Long division is obviously also to be used. A lot of students don't like long division, but I think long division can be more useful. Obviously, synthetic division, once you get down with it, it's very, very simple and very quick and efficient. But it is just a tool, so I'm not going to explain whole much into it. The main important things I want to understand is just like the idea of division. What we're basically doing, we're trying to divide this into that, just like we want to divide 3 into, now let's just divide 3 into 12. When I divide 3 into 12, that is 4, right? And what that means is 3 and 4 are factors, right? They evenly divide into 12. And that also means we can rewrite this as a product of 3 times 4 equals 12. That's very, very important. Now, obviously, I'm probably going to have a remainder here. So let's do something that is, let's do a problem that would not have a remainder. Like 3 divides into 13 4 times, and then we'd say it has going to have like a remainder of 1. But basically what that means is 3 does not evenly divide into 13. So that's kind of like one of the general concepts I just want us to understand here as far as like division and what that means with numbers compared to polynomials. Now again, in terms of polynomials, if something is a factor, that means you can find the 0. So when doing long division, or sorry, synthetic division, if we're going to divide this into that, then basically you can say like this is going to be your divisor, dividend, quotient. This is going to be your divisor. Now you can think about this as a factor. Now we haven't proven that this is a factor yet, but basically we want to test it, because if this divides evenly into that, then it is a factor. But when we're doing long division, we want to use this factor as if written in a factored form. When we're doing synthetic division, we want to figure out what the zero is. And that's why factors are so important as far as in polynomials, because all you need to do to go from the factor to the zero is just set the factor equal to 0. And then you get x equals 1 would be the 0. Now again, we don't really know if 1 is a 0 because we don't even know if it evenly divides into it. So that's what we're going to do in check. But the main important thing is we're going to use this positive 1, not this factor, for synthetic division. The other thing you need to understand, which should have been great to include, is make sure that you understand the coefficients here. All right, and obviously if you're missing an x, then make sure you use a 0. So if there was no x here, then you would have 0 as its coefficient. Now, all we're simply going to do is we're going to take that 0, or potential 0, I guess I should say. We're going to place it on the outside of like a inverted long division symbol. And then we're just going to take the coefficients. 1, -2, 1, 4. And the process for synthetic division is bring down the first term, which gives you a 1. So, and then you multiply on the diagonal. 1 times 1 is 1. And then you add on the vertical. -2 plus 1 is going to be a -1. -1 times 1 is going to be -1. 1 plus -1 is -1. And then, that's 0. And then 0 times 1 is going to be 0. And guess what, ladies and gentlemen? We have a remainder of 4. Now, when we're writing the equation, because sometimes you have to write the polynomial as a multiplication problem. So all we're simply going to do is you're going to take the remainder. This is going to be your constant. This is the coefficient of your linear term, coefficient of our quadratic term. And if you kept on having terms, like more and more terms, then you just keep on going to the left. These are all the coefficients. But it's important for us to be able to write this as basically a 1 x squared minus x. And then obviously I don't have a constant here, but then we're going to take the remainder, which would be 4 over our divisor here of x minus 1. All right. Now, obviously, if this was a factor, this, like, let's say the remainder was 0, then what you could do is you could set x squared minus x equal to 0, and you could go ahead and solve that by factoring to go ahead and find all the zeros of the polynomial, which is a very, very popular question. All right. I've never done synthetic imaginary numbers, but hopefully, yeah, you can do it with synthetic division. I'm just catching one. You could do one with synthetic division, but or you can do synthetic division with complex numbers. I used to teach it that way, and if you look at my videos on synthetic division, I do have quite a bit of examples on there. I don't teach it that way anymore, particularly when rather than doing synthetic division with complex numbers or with doing it with irrational numbers, I prefer to multiply the given 0 write the 0 as a factor, and then multiply it by its conjugate to therefore get a quadratic factor, and then use long division. And I've found in just my experience that makes the math easier to be able to complete. All right. Well, the 2's in front and the y in the middle, with 2 x's in the front and y in the middle. It doesn't matter, Matthew, as far as the order of the x and the y's. Just switch them around however you need to. So, as long as you're keeping the coefficients the same, then, as far as the sign goes, as like positive and negatives, it's not going to matter. Your main important thing when doing substitution is you want to identify the variable that has a coefficient of 1, and that's the one you're going to solve for. If none of your variables have a coefficient of 1, then I would just use elimination. I don't know why you would have to use substitution, because I just don't see there's really a point to forcing you to do substitution. Find the variable that has a coefficient of 1 and solve. And again, even if it was, like, just real quick, just because I noticed your comment, like, so what? If it was -2x, like, plus y equals 1, you would do the same thing. You would just add a 2x to the other side, and then you've isolated the y. So just use your inverse operations to go ahead and solve. Yes, it does. I mean, it would yes, it does work. You just have to do synthetic division twice. You have to do it for the 0 as well as for the conjugate 0. Levant. All right, let's get on to exponential and log overview. I'm not going to get deep into this because, again, it's not something that we cover right now. But let's just kind of take a look at the exponential graph and kind of look at its kind of properties, and then just really kind of understand a couple things from there. So if you were to have, now we're going to use, let's just do y equals 2 to the x. Okay, so if I was going to basically go ahead and graph y equals 2 to the x and then create a whole bunch of values, plug them in for x, and then get from y, either way, what you're going to get is you're going to get a graph that's going to look something like this. Now, that is usually where I kind of start with exponential functions. That's where we talk a lot about, doubling your money. We look at growth. We use that formula. And then we start to introduce e, which, again, is going to have the exact same shape of the graph, the same intercept. It's going to be a little bit more vertically compressed here. But the main important thing is it has this y-intercept at 0, 1 here. And it is going to increase a little bit faster than the 2 to the x. Okay, but that is your exponential equation. Now, to look at the logarithmic equation, they're inverses of each other. And if you remember, inverses are reflected about the y equals x line. And again, the importance of them is they are, you're in, well, I'll get to that in a second. So if I was going to take this graph and reflect it about the y equals x line, then my logarithm now is going to have an x-intercept at 1, 0, and it's going to look like this. Roughly, it's actually kind of shoots down a little bit faster. Now, there's some other important things that we need to look at here, because I didn't really get into everything I should. All right, so when we look at this exponential growth, as we kind of go to the left, what you see is this graph, it looks like it's approaching 0. It's actually not crossing, going to be 0, and we'll kind of make sense of that, as well. But if you can think about that, if you have 2 and you raise it to a number, it doesn't matter if it's a negative number. Well, again, if it is a negative number, that's just going to make it a fraction. Right, if you have y equals 2 to -1, that is 1/2. So what happens is, as we get larger and larger negative numbers, that's just getting smaller and smaller fractions, but it's going to get closer and closer to 0. So it's not actually approaching 0. Or I'm sorry, it's not actually going to cross 0. And then if we have larger and larger positive numbers, that's just going to shoot up. So what it means is that we actually have a horizontal asymptote here. And why that's important is you can see now our range is going to be from 0 to infinity, and our domain is all real numbers. Now, when it comes into the logarithmic function, if you remember our relationship between inverses here, our relationship between our inverses, the domain and ranges are swapped, and you can see, if there's a horizontal asymptote here, now what we're going to have is this nice little vertical asymptote at the x-axis there. But so therefore the domain is going to be from 0 to infinity, and then my range is going to be from -infinity to infinity. All right. Now the only other thing I want to kind of mention, because obviously the reason why logarithms kind of comes up, or why it's important, is when you look at this, y equals 2 to the x. Well, what if I need to solve for x, right? Now, when we had x in different spots, for instance, x, let's do the I don't know, x plus 3 equals 5. We need to solve for x, we just use our inverse operations, right? And that's easy. But when you're looking at this logarithm, you're well, how am I going to solve for x when it's raised to the power? 2 is raised to the power of x. So I need to undo that, take that off to that power of x. And that's what the logarithmic function, which I forgot to write here, that's what the logarithm is doing. Okay, so if we want to write this in exponential form, all right? So let's kind of maybe look at another way. We could look at like 9 is equal to 3 squared. That is another like exponential equation, right? We know that 3 raised to the second power is equal to 9. So another way that we can write this into logarithmic form is the log base 3 of 2 is equal to 9. So in this case, when you're looking at this, and I don't like using this notation because the x and y's, remember inverses, they're going to be swapped in that ideal, but you would just write this as log base 2 of y is equal to x. And now you can see we are solving for x. So this is what we call our exponential form, and this would be called our logarithmic. And without getting too much into logarithms, basically when we're looking at the, oops, what am I doing? I like wrote that that's 3 raised to the 9 equals 2. 2 raised to y. Yeah. So again, the main important thing that I'm just going to cover, and I don't want to get too much into this because it is kind of a vague topic that we are going into, is, 3 raised to what is 9? And obviously we know that answer is 2. Okay, so when you're looking into that logarithm, like this one saying 2 raised to what value of is y? And obviously in this example, that is going to be x. And obviously we could rewrite that like if this was 8, then obviously this would be written as log base 2 of 8 equals, and obviously that's going to equal x, which we know is equal to 3, because 2 raised to the third power equals 8. So that's just kind of a brief little overview of logs. I'm not sure if that helped, but hopefully anybody that's watching that may have helped. I mean, 2 x's in front. Yeah, I know. I'm just going through. Oh, man. All right. Let's go and look at the next one. Trig identities. Man, I don't have any trig identities like prepared. What I can do is let's kind of go over here's what I'll do. I don't have any identities covered, but what I'm going to do is I'll cover some of the basic identities that you need to know. So I'm just going to do like a little overview session. So step number 1, apply the basic identities. So actually, forget that. First step is you need to pick a side. Okay? So when you're looking at an identity, you basically have an expression on the left side and an expression on the right side. You just need to pick a side and work on that one side. And typically, what you want to do is pick the side that looks the most complicated, or looks the most complicated. So, like a lot of times, you'll have a whole bunch of stuff on one side and then like just one, function on the other side. Well, obviously, do the one that's on all the other side. Sometimes they look the same, or they look like equally as complicated. So my advice to you there is to just pick a side and see how far it takes you. Also, if you can see that like, 2 of them are 2 separate fractions and then the other side is a single fraction, well, usually it's easier to combine 2 fractions than it is to break apart 2 fractions. Sometimes it's easier to multiply than it is to factor. So, usually kind of pick when you're looking at something, or if one thing is a fraction and another one is a not, it's usually easier to simplify the fraction rather than, create a fraction. But again, that just kind of comes in with experience. Number 2, look for your basic identities. Okay? And what I mean by basic identities, and again, like there's so many examples. I was actually creating my notes for this topic, which we'll be teaching when we get back in 2019. And I have like so many examples I'm going to be doing in this topic. And because there's just so many variations you can do. But you want to make sure that you try the quotient. See, like for the tangent and the cotangent, if you can break those up. Look into seeing if the reciprocal identities are helpful. And obviously the even and odd are kind of obvious, as well as the cofunction identities. Okay? Now, those are kind of like the basic ones. So this is basically going to be more, basic identities that you're going to do. You're going to want to look into apply those. A key little point, you don't need to use every identity. So I get this a lot. What will happen is, like, for example, I'll have somebody do, let's do a constant one, sine or tangent, sine over cosine. So we'll have this one as like tangent, times cosine. And then, so the basic thing to do here, and like that equals sine, right? And I guess we should have some x's there. So what people do is they'll work on the left side and say, okay, well, I'm going to convert this to sine of x over, cosine of x, and then I'm going to convert this to 1 over secant. And it's like, no, you don't have to convert that. You want to leave that as a cosine, because if you leave this as a cosine, right, because now you can't do anything. So you don't have to convert that cosine. You don't have to convert everything. But now that you see that this is a cosine, you can see that now those divide out, and then you have your sine of x equal to sine of x. Okay, so don't worry about trying to convert everything to using the identity. Now, once you've kind of looked at the basic identities and you're not seeing anywhere going, then the next thing I do is look into your Pythagorean identities. And remember that the Pythagorean identities is basically going to be when you have stuff squared. Okay, so whenever you see sine squared, cosine squared, cosecant squared, tangent squared, secant squared, all the squared functions, look into applying those identities. Look to the Pythagorean identity. It's not always the best case. It's not always the best, route, but I would definitely say look into going down that route for you. What else? All right, so the next one that I'd say is to, if you're still kind of getting a little stuck here, but look into, like, just convert to sines and cosines. So sometimes, sines and cosines makes them more messy, but a lot of times it makes it easier. It's very easy to kind of see what is going on. All right. And I like to kind of do this first, just so you can kind of see if these kind of steps don't work, then just convert everything to sines and cosines, and then just kind of see what's happening. Kind of see, like, what is it you're trying to do? Like, are you trying to combine two fractions together? Are you trying to reduce a fraction? Are you trying to combine, like, certain terms together? And typically, if you're getting stuck up to this point, that means because you need to apply an operation. And when I mean apply an operation, I'm talking about, multiplying, factoring, add and subtract fractions, also, a lot of times you need to rationalize the denominator. And rationalize the denominator. And what else? The other one? Oh, and then like multiply by. So if you're dividing, you could also and also divide. I don't know why I did that, but a lot of times what we do is multiply by the reciprocal. Okay, and so I'd go ahead and try those, and I'm not sure if I'm forgetting one else. But again, a lot of times what's going to happen is you're going to get stuck again. You're going to do all this work, and you're like, crap, I'm still not getting it. So what I would look into is try, and then try again. Like, if you're doing, like, obviously if you tried it one way, try a different identity. Like Ray said, like, don't always try to do the same identities. Try different identities. Try doing different operations. If one side's not working, try the other side, right? But just keep on going back, work through all of these, and eventually you're going to start picking up on some tips that will help you out. So hopefully that was helpful for you. It looks like you guys are enjoying yourself in the chat for you guys on there. So at least I apologize for all you guys that have joined in. that I haven't been able to answer any more recent questions. I'm just going to be covering what I have going on here. So, all right, that was trig identities. So quadratic word problems, I don't have anything for quadratic word problems, but what I'm basically just going to do is, remember that when you have y equals ax squared plus bx plus c, then you're basically going to get some equation, particularly most likely that's going to be in standard form. Usually the main things that you're going to be looking into is graphing, and most word problems, are dealing with the path of some kind of projectile or something like that. A lot of physics problems here. But again, make sure you're looking for a lot of times what we're looking for is certain like heights and times. So, this is going to be that, remember that vertex, which here is our vertex. So that is going to be the max, I'm just going to talk about projectile. That's going to be that max height, which is the y coordinate. So the y value of that vertex is going to be your y coordinate. And then the time, like assuming we're talking about time here, I'm just like making up some problems. The time of the max height is equal to x in this case. So that's going to be your x and your y. All right. And then obviously we have this other point, which would be your zeros. And these are going to be your x and y intercepts. So, typically, obviously we learned in Algebra 2 how to do this algebraically, finding the zeros or the x-intercepts as well as the vertex. When typically we're doing a lot of word problems, you're going to be using a calculator to identify a lot of this. So obviously I don't have a word problem, and we don't have time to kind of work through a wrap problem, but hopefully you can kind of use some of this information to make sure that you know how to find the vertex. And obviously there's a ton of tutorials online to find the vertex using a graphing calculator as well as the intercepts for you. So sorry, that wasn't probably the best what you came here for, but hopefully maybe it might have given you a little bit. All right. Let's see. Quadratic word problem. So solve radical equations. Man, I haven't done the 2x plus 5 minus square root of 3x minus 2 equals 1. I want to work on I'm just trying to think, because I know if we square it, then we're going to have to check our extraneous solutions. And I remember doing these problems. I'm just trying to think what exactly I want to do. All right, let's just go and play around with it. So, to be honest with you, it's been a while. We used to cover these. Obviously, I do a lot of these in my Algebra 2 class, and then I haven't. Take it away from there? No, okay, it's still there. All right, let's just go and play around with this. I might have to fumble because it's been a while, and obviously we're doing. Oh crap! I'm going over an hour. Jeez. Oh, pen. All right, so typically it's not good to go ahead and square things. That just means when we square, we're changing the equation, so we want to make sure we're going to have to go back and check for extraneous solutions. But let's go ahead and if we go ahead and square this, so if we square both sides, let's see what happens. I don't remember doing a problem like this, so it's been so long. So that is going to be square root of 2x plus 5 minus the square root of 3x minus 2, and this one, and then times square root of 2x plus 5, and then minus square root of 3x minus 2 equals 1. And so therefore we multiply this, that's going to give me a 2x plus 5. And then we're going to have a minus 2 Oh, let's multiply this. So that gives me 2x plus 5. That times that is going to give me a square root. Yeah, square root. So it's going to be a 2. There you go. Oh, I'll just write it out there. Square root of 3x minus 2 times 2x plus 5. This is going to be, and then those two, it's going to be a minus 3x minus 2 times 2x plus 5. And then that's going to be a minus 3x minus 2. Yeah, that's not going to work. It's probably should add that to my other side and then maybe change. But I don't want to get down a rabbit hole and spend all my time doing this algebra. I don't remember, to be honest with you. It's been a while. The right correct path is not coming to me. And I don't want to spend all my time doing this algebra just on one problem. But let's just go ahead and take a look at one more way to get rid of the radicals. What about if I added this over here? And now go ahead and take the square. So now, by doing it that way, I obtain a, square both sides. Now I obtain a 2x plus 5 equals, now this when I multiply by myself, I'm going to get a 1 plus 2 square root of 3x minus 2, and then that's going to be plus 3x minus 2. So by doing it this way, you can see now I have these radicals solved here, and then I can just go ahead and combine 2x plus 5 equals, let's see, a negative 1. The 1 minus negative 2 plus 3x plus 2 radical 3x minus 2. That's a plus 5, so let's add a 1. 2x plus 6 equals 3x plus 2 radical 3x minus 2. I'm trying to isolate my radical now. So I'll subtract my 3x, so I get a negative x, and then subtract a 2. And by subtracting my 2 here, I'm going to get a 4, and, I can't subtract a 2. That's multiplied. Can't do that. So you subtract the x, you get plus 6. All right. Oops, pen. I wanted blue. Plus 6, and that's going to equal 2 radical 3x minus 2. And then I can divide by 2. It's now going to be negative 1/2 x plus 3 equals the square root of 3x minus 2. And then if I square both sides again, I can now get rid of my square root. I am not going to continue working on this problem because I'm not sure if I remember my method as being correct. But then also I know that it's going to take me much longer now to expand that, combine like terms, and then find the zeros for x. And then just remember, since you square both sides, you're going to have to go ahead and plug it back in. So yes, 1 square, it's going to 3. Square both sides again, lol. Yeah, I mean, that's basically what you're doing again, and keep on going through, and it's going to be, it seems like everything is working out okay now. Obviously, go and expand it, but it's just, I don't want to be spending too much time doing this algebra. I do appreciate the problem, but I probably should have had some problems a little bit set up here to go from there. So on the next one, so I'm just going to move. Hopefully, at least I got you kind of started. And you can see what happens when I just squared both sides, how it became like a mess. But now by putting the radical on one side and then squaring both sides, it kind of made things a little bit easier. To apply the difference quotient here is x squared minus x. So obviously we're just going to work on evaluating for it now. And then x squared minus x. I'm not sure what your exact question was. So we'll just kind of go with if f of x equals x squared minus x. All right. So now basically what we're going to do is we're going to replace this function with all our x's with x squared plus x. So it's going to be x plus h squared minus x plus h. So wherever you see an x, you're just going to replace it with an x minus h. And then you're going to subtract that from f of x, which would be minus, again, I'm going to use parentheses, x squared minus x. So this is the f of x plus h right here. And then, so basically this is your f of x plus h. And this is your f of x. And then you have your h. Now, we don't have a limit, of anything going on there, so I'm just going to simplify, and we can see how this gets, I'm just going to expand this and simplify. So x plus h squared is going to be x squared plus 2xh plus h squared. Distribute that, so that's a negative x minus h. Here I'm going to distribute that to a negative x squared plus x, and that's going to be all over h. And now we can see here we have a positive x squared and a negative x squared. We have a negative x and we have a positive x. And so then, let's go back to blue. So what we really have is a 2xh plus a h squared minus h over h. And if you're just looking into simplifying, if you can factor out the h from the numerator, let's actually move that over. Then when I factor out an h, I'm left with a 2x plus h. Why is my h? 2x plus h, okay. Yeah, that would go fine. 2x plus h, and then minus 1. And that would be over h, and therefore I would get a 2x plus h minus 1 as that factored out. And then I'm not sure as this goes into, 2x minus 1. Obviously, you'd be looking at the derivative if you wanted me to talk about derivatives using the power rule, which is where we get our 2x minus 1. As h would approach 0, which is not sure to get into, but hopefully that math helped you guys out. All right. Cool. Guys, how many more do we got? Man, there's a lot of chat. Jeez, oh man, you guys are doing an awesome job here. All right, difference quotient, we cover that. So, as far as what I do for number 9, I'm not sure. It's been a while since I covered radicals. Or not radicals, but exponential in that form. Basically you're going to be looking into trying to solve for x. All right, let's just go and play around with the number 9. I don't know why I'm doing that. So no. Well, all right. So let's go ahead and just take the ln, which would be log. Well, we want to go and take let's go and take ln of base 2 because we got to get rid of the logarithms. And one of the rules of logarithms, if you remember from our logarithms, if you have like the log of 3 to the x, well then that's just equal to x, and that works for any base. So what I'm going to do is I'm going to take the log of base 2 of 2 to the x squared equals log base 2 of 3 to the x. Okay. Now, obviously, I can't eliminate this, but now I can use a different rule of logarithms, which basically says if I have log base 3 of x squared, I can bring that 2 in front and rewrite this as log base 3 of x. So that's the second rule that I'm going to use, the power rule. So anyways, this just gives us an x squared. And this one, I can rewrite this as a x times the log of 2 to the 3. And now to go ahead and solve this, I would go ahead and set this equal to 0 since it's a quadratic. And so I'd have x squared minus x log base 2 of 3, whatever that is, you're going to have to use a calculator. And then I can factor out the x, and I'm just left with x minus log base 2 of 3 is equal to 0. So my solutions are x is equal to 0 and x is equal to log base 2 of 3. Hopefully. It's been a while, but I think everything looks right. I don't think I violated any rules doing that. And then obviously you'd have to use your calculator for that. I don't know what that approximation is. But you could use the change of base formula or some calculators now. You guys can plug it in. All right, let's work on the next one. Derivatives. So I kind of covered derivatives. Basically, guys, we're looking at the derivatives just to kind of do a quick little thing. Derivatives is, I don't even want to get into it, but it's, you're looking at that rate of change based on the graph, but obviously it's getting late, and you can identify the derivative actually by applying this difference quotient here. This will give you, this is what we call the difference quotient, and that is going to help you apply the derivative. And for many problems, it's not going to be the preferred way to do the derivative, but when you first learn about derivatives, that's what we do. So with basic functions, you can go ahead and find the derivative, which we use that f prime of x notation. So that's about as much I want to get into the derivatives, just because obviously I think it's a much deeper topic than me talking about it for a couple minutes is going to do any justice. Let's just go and solve an absolute value equation. That's something simple I can make up as we wrap this up here. And again, for any of you guys that are joining in live, I've been going live here for a while now, but I do apologize. I'm kind of cut off my answers here, so I'm just going to cover what I can for you guys. All right, so let's just say we have 3, x minus 2 minus 1, and I am going to make up a problem here. Let's go ahead and treat this as 3x minus 2, 11. Okay. So the main idea that when we're solving an absolute value equation, the main thing we want to make sure we do is go ahead and isolate the absolute value. All right. And again, the reason why that is so important is first, let's just look at the graph. That's what we famously known as the V graph, right? Now, again, notice there's two solutions. Like if I had this graph shifted down, right? So this is y equals absolute value of x. What if I had like y equals absolute value of x, like minus 1? You can see now there's these two solutions. There's this positive as well as this negative solution, right? So we understand from the shape of this graph that we got to make sure we check for our two solution case. Now, obviously, it could be possible for there to be no solutions, and we'll take a look at when that is possible as well. Because obviously, you could look at the graph like this as well. Like y equals absolute value of x, plus 1. And you can see there are no solutions. There are no x-intercepts. But either way, to solve an equation, you need to isolate the absolute value. So what we're going to do is we are going to undo all the operations that are being applied to the absolute value first. So I'm going to add the 1 using my inverse operations. And then I'm going to divide by 3. And now I have the absolute value of x minus 2 is equal to 4. Okay. Now again, kind of going into this understanding, what we're going to do is we're going to create our two cases. So notice here, just by having this as like a vertical, we could also rewrite this as x minus 2. like -4. You can see there's some transformations that are happening. The graph is being shifted 2 units to the right and being subtracted down 4. But what we want to do is take into consideration there's 2 solutions. So we need to create 2 different cases. Like when we were looking at a quadratic, we didn't have to create 2 different equations. We had that x was squared, so that gave us our 2 cases. In this case, if you just solve this, if you just do x minus 2 equals 4, you're only going to get x equals 6, right? And that's only going to be possible if there's just a horizontal shift, like no vertical. So we know there's a second case, so what do? And the idea, comes from the absolute value. Remember, like the absolute value of, -4 is 4. The absolute value of +4 is going to be 4 as well. So when we have the absolute value of x, we don't know, is that -x? Or sorry, no, sorry about that, not that. If we have the absolute value of, or if we're given x, right, we don't know, is that the absolute value of x or -x, right? So what we're going to do is we're just going to negate what the absolute value is equal to check our other case. And I just add a 2 to both sides, and I get, in this case, x equals -2. And those are our 2 solutions. When you have an absolute value equal to a negative number, that is your no solution. So if you have like -x is equal to a -5, that is going to be no solution. Okay? And you can see here, if you were to set y equals 0 and solve, you'd get no solution. So the main thing is isolate the absolute value and then set up your positive and your negative case. And that's going to give you your 2 cases, because the absolute value is not set up for those 2 cases, as far as at least understanding the positive as well as the negative. I don't know why I keep on using that. Solve absolute value, and then we got 8/6. And then I'll do an area and perimeter, and then a factoring problem. And that should be it. Okay. So I'm almost done here. Yeah, getting comfortable with Algebra 1. Cool, guys. So yeah, I'll just finish up these last 3 problems, guys, and hopefully that has been helpful for you guys. For any of you that are paying attention, or guys just chatting with each other, that's cool too. Maybe the replay will help some people out. I don't know. All right. Next one. Let's solve a inequality. All right. So the main idea, guys, is when you have an inequality, you got to get the x's on the same side. So I am going to get this 8 to the other side. And then I have 8 over, now I can reduce this 8/6. I'm not sure if I copied it down wrong, but I would reduce this to 4/3 x, and then is greater than 2x plus 8. Now I'm going to subtract a 2x on both sides, and we're going to want to write 2x in terms of thirds. So 2x is the same thing as 6x over 2. No, over 3. Right? 6x divided by 3 is the same thing as 2x. So by rewriting this, now I can combine these fractions. So I have 4x thirds, and then this is minus 6x thirds, and that has to be greater than 8. Well, now they have common denominators. 4x minus 6x is a negative 2x over 3 is greater than 8. And then now I'm just going to multiply by a 3 on both sides. And then I get a negative 2x is going to be greater than 24. Divide by negative 2, divide by negative 2. Remember, when you're dividing by a negative, you're going to want to flip the fraction. So that gives me a negative 12. And then we typically want to graph, because that's all values that are less than negative 12. So I'm just going to create a number line with negative 12 being right there. And I want to show all values to the left, not including 12. So we'll go right there. All right. Mohammed, you have been waiting patiently. I don't know what kind of problem I can help you out with, but I'm just going to try to do my best here for area and perimeter. So Yeah, let's see here. I mean, I don't know if you want me to do like a rectangle, a square, a triangle. I can cover anything you want, but it kind of helps. I hate that app. So let me know as far as the area that we're looking into. So we can cover rectangles. I'm not sure if you guys in like 4th grade or whatever else, if you guys cover trapezoids. You know, from there, it really kind of, we could do an equilateral triangle. We can do an isosceles. Oops. We could do a scalene. I was just kind of seeing any kind of period. Well, let's just kind of go through the area of all of these. So we'll let's do a rectangle, square, triangle. Rhombus, you'd have to go ahead and find. Well, not a rhombus. Rhombus, I was thinking trapezoid. Trapezoid, you just have to find those lengths. But basically, remember the area is basically the space within the enclosed figure that the figure makes up. But Mohammed, if you do have some questions, 4th grade rules, it is a pain. Yeah, I'm not really sure what to do in 4th grade. So I'll try to explain this the best I can for you. But the area is basically the space that is enclosed within the figure. All right. And, you know, there's actually a lot of better understandings to do this as far as like creating a grid to understand the space that this shape takes up. But if I want to find the area here of this rectangle, you know, one thing we look at is you can see that this one is so long, and then, or we could say here is our length, and then here is going to be our width. And I'll just call this my width. Okay, so it's length, it's this long and this wide. And basically what you can do is like, what I was trying to like understand here is you can kind of break up this width. Like if you were to kind of break this up into rows here, that's why like the multiplication makes sense, because basically what you have is you have W number of these vertical rows that are L long. So if you want to find the area, you're basically asking us to find how many of these bars, you know, basically make up this graph. Now, obviously W, we don't know how many bars because we could do really small ones, really big ones. But again, just the basic idea as far as finding the area here is going to be length times width. Now to find the perimeter, that's basically going to be like the distance around the figure. Basically, if you were to walk around the figure, how far would you have traveled? So what's nice about a rectangle is we know that our opposite sides are the same length or congruent. So therefore, if we know this is L, then that is L. And if we know that is W, then that is W. So if we were to add everything up, we could do it like a walk, L plus W plus L plus W. But that's not very neat. So what we can do is we can combine the two L's and we can combine the two W's, right? Because like an apple plus an apple is 2 apples. So we have 2 lengths. So we'll say 2 lengths plus W. So that would be your simplified form. And then you could just multiply and then go ahead and add. The nice thing about a square is that we know that all the sides are the same. So again, the same principal idea of area is going to take shape. But now we can basically just think of, well, if we already know what one side is, it's just going to be L squared, hence square, L squared. Like you're just going to do L multiplied by itself because all the sides are the same. And as far as the perimeter, the same thing. Instead of doing L plus L plus L plus L, you can just find the perimeter as 4L, like whatever one side is multiplied by 4. Now, as far as, well, I guess the scaling wouldn't work because you would really need to figure out what that side is, and that's definitely not in 4th grade math. So let's not work on that one. But the reason why I chose an equilateral triangle, all the sides are the same, is because, you know, obviously that's something easy you can find the area for. Or I'm sorry, not the area, but the perimeter. But basically when we want to look into a triangle, and actually the easiest thing to look at a triangle actually would be from a rectangle. So if you have a rectangle and you draw a diagonal, you can see that it looks like it's like half of a rectangle, right? If you have the length and you have the width, it looks, you're like 1/2 of that, right? And that's exactly the area of a triangle, is 1/2 length times width. So sometimes, though, we don't have like the length and the width, or if an equilateral triangle looks like this. So sometimes what we can do is just draw a line here, and then still you do the same thing. We could also call this sometimes, say that is going to be your length, and then this would be your width. So sometimes when you're looking, you want to look at that picture and draw, but you don't want to use this diagonal from this thing. Notice how I'm doing these angles, that they are what we'd call perpendicular, this length and the width, right? Because again, we want to use the idea of this of the rectangle, not using these diagonals, because that wouldn't really work. So sorry for my 4th grade explanation, and yeah, I know I literally have no idea. So you've obviously been staying in the chat for a long time, so hopefully that helps. I don't know if there's anything else. What else I could help you out with as far as from there. But I mean, obviously you'd probably have some different side lengths as far as finding the sides to help out. So all right, let's go and look at what else do I have left. Error parameter factoring polynomials. All right, guys, we are at the end. I am almost going live for almost an hour and a half, just about. Jeez, cool. All right, so let's just do some factoring polynomials. I'm just going to remain in quadratics, but I'm going to pick it up. So let's just do one that we know how to do, and then I'll just kind of expand upon that. And hopefully this will help some of you guys that are working on this. David Mercado, I'm just going to have a video, origin, story for yourself. You saw our computer died back and phone what's up. Hey, meme guy. Glad you could come back. Yeah, I do have a video. I have, if you just search my channel, like my story, it's an older video. I really want to redo it. And actually it's only like phase 1 of my story. And I have like 4 different ones, that I want to make. And I've just been like so busy on the idea of, making additional videos, but you can go and watch it. It's okay. But yeah, but it does explain a little bit as far as like how I was in high school and kind of stuff like that. So, all right, let's go and do some factoring. So, I'm not going to get into the, I teach a lot of different ways. So let's just look at, if we needed to factor x squared. I got an idea what I can do. Let's do this. X squared minus, I know what I'll do. X plus 3x plus 2. Then we have x squared minus 3x plus 2. X squared minus 1. X or minus x. Minus 2, and then we have x squared plus x minus 2. Okay, so guys, there's a couple things that get into me. Like for when I used to teach algebra 1, used to teach algebra 2, like number one, the thing that students struggle with the most was factoring. And I think a lot of it was, so therefore, as a teacher, what we do is we revert to all these special techniques and way to like understand factoring and whatever else. And it worked. Like students could do the factoring. They could follow this algorithm to factor a quadratic expression. But what I found is once the students got into like algebra 2 honors or into pre-calculus, either they forgot completely how to do that method, or 2, it just would take them too long to do the method. And as a pre-calculus teacher, that's kind of more primarily where I'm going to, because, factoring is a tool, right? It's not something that everybody and you need to know for like in your real life. It's not going to be that important of a skill. Obviously, if you're going to become a math teacher or take a lot of mathematics classes, you will use factoring within those techniques. But as far as like a day-to-day job, you don't hear so many people. I'm like, oh man, I did so many factoring problems today. So it's a tool. It's like multiplication, right? We want you to know your multiplication. We want you to know how to multiply 6 times 6, so you can understand that, and maybe you'll use it a couple times here and there. But in reality, anything advanced, you're going to use a calculator for. So, factoring is important. And it's a very important mathematical tool that we use. But I'm not very big into just memorizing some, new creative way to do the factoring for it to make, I do teach that, as far as an algebra one, like an understanding the factoring technique, because I think it's very important to understand it before you just do it. But I'm going to approach these 4 problems from more of a advanced sector, as far as saying, hey, once you understand the basic idea of factoring, I need you to be able to do these problems. Now, I will tell you, I gave my students like over 100 problems of these types of factoring problems to do. And all I did was I kept things very simple. Nothing was over the number 4, I think, or number 12. So when A is equal to 1, I think I kept everything between 12. But I did every single example of factoring that you could possibly do with integers. And what I was trying to do was build their confidence in the numbers and their relationships. And so I'm going to pick 4 here that I want you to understand what I'm doing, because I think if you can master the factoring with smaller numbers, you can now start expanding when you do have larger numbers or higher order polynomials. And that's what I'm going to do. I'm going to go from here, and then I'm just going to kind of further elaborate this factoring. But so my dog's staring at me because she wants to go outside. But I'm going to try to finish this problem here for you guys. Yeah, you guys are getting it. Yes. And it's, pretty simple, right? I mean, again, when we're looking at factoring, we're basically all quadratic trinomials can be factored as a product of 2 binomials. And if you guys remember from like multiplying with FOIL, right? You have your first, well, I don't want to use that. Let's just use an. But like if I had, x plus 3, all right, let's do the first one. Oh, why am I doing that? Let's just do the first one. So anyways, this is going to multiply into there because we know that our first 2 terms always multiply to give us our x squared. That was like our FOIL, if you remember that, if you use that technique, right? And then the last 2 terms multiply to give us 2. So what 2 numbers multiply to give us 2? And then, we want you to be able to do this in your head. Obviously, some numbers are not as easy as other numbers, but it's either positive 2, 2 and 1, and negative 2 and 1. Let's just go with a guess and saying that 1 is going to be 2 here and 1 is going to be a 1 here. Okay, so we have our outer. And we have really no other options, right, guys? I mean, it's either 2 and 1 or 1 and 2. And then what we notice here is, I'm sorry, that's the last. These are your last terms. So we know first times first is x squared. And then 2 times 1 is a positive 2. Now all we got to do is make sure that our outer x times 1, which is x, and our inner multiply, because when you multiply using distributive property or FOIL, is going to give you a positive 3x. So I get x squared plus 3x plus 2. So therefore, guys, you can see that this is factored correctly. Now, obviously, I'm picking a very easy problem because a lot of students have trouble with factoring. And I could do some harder examples and just show you the answer, but I think you really need to practice with the very, very basics. So let's pick it up now a little bit. So in this problem, I know it's going to be broken down into a product of 2 binomials. I know my first 2 terms are going to be x and x. I know I need to get a positive 2, so both factors are going to be positive, both factors are going to be negative. But they need to add to a negative 3 this time instead of a positive 3. Well, when they're both positive, they added to a positive 3. That means if I make them both negative, they're going to add to a negative 3. And I'm not going to check my answer this time. You can multiply it yourself. X squared minus 3x. Basically, what you want to do is just multiply your inner and your outer to make sure it verifies, and it does. Now let's go and look at the same one. Oh, it's the same factor. It's going to be a product of 2 binomials, right? So that's going to be x and x. Now, this is where it gets tricky because your outer term is negative. So now for a negative 2, it can be negative 2 times 1, or it could be 2 times a negative 1, right? And so now what you got to do is look at this middle term. Well, since the middle term is negative, what that means is I'm going to want the larger of my 2 products, of my inner and my outer, to be negative. So I'm going to want the 2 to be negative and the 1 to be positive. Because when I combine my inner and my outer, negative 2x plus 1 times x is x, you can see how that gives you a negative x. So that is my factored form. And then on this last one, I know it's going to be a product of 2 binomials, right? need to give me negative 2. However, my middle term is now positive, so therefore I'm going to want this to be a positive 2 and this one to be a negative 1. And hopefully you can see how this variation, see how what happens when you have, and basically all I do when I'm factoring is I look at the last term and the middle term. Last term and the middle term. Last term and middle term, last term and middle term. And again, what you're doing is you're looking for what two numbers multiply to give you that last term, add to give you a middle term. And again, that's a very generic description because obviously factoring problems when a is not equal to 1 can get a much more advanced very, very quickly. But let's just go ahead and expand on these. What I'll do is I'll give you guys, a couple different variations of these that, you guys could see. All right. So what if I gave you 2x squared plus 6x plus 4? What if I gave you a x cubed minus 3x squared plus 2x? What if I gave you a x to the 4th minus x squared minus 2? And then what if I gave you a x to the 6th plus x cubed minus, now let's do this one, x cubed. Wait, x cubed, yeah, x to the 5th. X to the 5th. Let's do this. Sorry, I keep on changing it up. Let's do 2x to the 5th. There we go. 2x to the 5th minus 2x cubed minus 2. Oh, I got an idea. Let's make this a negative. Minus a 2x. And then let's make that negative, positive, and positive. All right, sweet. So when you say factoring when you say factoring polynomials, I mean, obviously our basic comes with quadratics. And so if you don't understand factoring quadratics, factoring these are not going to make any sense to you. All right. Now, the main idea here is, the first thing whenever we're factoring polynomials is always look to factor out a GCF. And you can see that all of these values I can factor out a 2. So that's going to do first, and I get x squared plus 3x plus 2, and you can say, ha, 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 that really wasn't that hard. That's the exact same function there, so therefore I can factor that. Okay, but look for it. It's important. And not only can 2 be your GCF, or a number, but you can also factor out an x. And that's exactly what I have in here. In this case, I can factor out an x. So when you're looking for an x cubed, look for that factoring that out. So that become a negative 3x plus 2, and then you're like, oh, I can factor that now. Now, obviously, guys, I'm a little limited on the type of problems or the number of problems that I can do here because obviously we could do some more advanced ones. But when we look at this problem, you can say this one doesn't have anything common to factor out, right? So let's just go ahead and think of this as squared. Let's think about this as how it was for x squared minus x minus 2. If I was going to factor it in that way, then it was x minus 2 times x plus 1. And that was because my first times first gives me x squared. Well, now I need first times first to give me x to the 4th, right? So what I'm going to do is I'm just going to raise the power of my factors. Negative 2 times 1 is still negative 2. And then let's check our middle terms. Negative 2 times x squared and 1 times x squared adds up to give me negative x squared. So good. And then on this last one here is you can see our GCF here. I got to the 5th power. I have a negative. So if we factor out a negative 2x, because they all share an x, I'm left with a x to the 4th minus an x squared and then minus a 1. And you can see now it is exactly, oh, did I mess that up? Dang it, I did. 2, that's supposed to be a 4. Obviously, that is non-factorable anymore, so don't want to work with that one. All right, so then that would be a 2. And now you can see that we can go ahead and factor that one down. So we'd have a negative 2x times x squared minus, did I mess that up? That was supposed to be, oh, yeah, multiply the negative. Oh, crap, that was supposed to be a negative. Well, let's change this in case maybe anybody's watching and in the end they won't know. I want to make it the same as this one. So if I factor out the negative, that's positive, positive, negative. Okay. So let's make that a positive. So therefore x squared, in this case, it would be plus 2, and then x squared minus 1. And that works now. Okay, so I'm not sure if there's anything else you guys need for the first one. Oh, there's a GCF and okay, no worries. Wait, that's a prime trinomial alerts. Which one are you talking about? For the second? Yes, I believe. No issue. I don't know. Are you guys seeing any other ones? Yes, that's, oh, maybe you guys are checking in the chat. Okay. Well, either way, the only other thing, also guys, with polynomials, obviously you have the sum and difference of cubes. You have factoring by grouping, which is another common technique. But basically, I would say majority of the problems that you're going to be dealing with factoring is going to be based off the trinomial. So if you can, really practice on factoring quadratics, and I would really just focus on being really, really good at factoring quadratics when a is equal to 1. When a is equal to 1 from numbers 1 to 12. And, if you're interested, I have that worksheet, that I'm more than happy to share with you guys. What I'll do is I'll put it in this, description once I get this video uploaded for you guys. And therefore, anybody who wants to practice their factoring can go ahead and upload, or go and check that out. But otherwise, guys, it is late at night. I need to go to bed. I appreciate you guys joining the stream, but I am out of here. Peace.